My dear students, in today's video I like to start another video lecture on block diagram reduction technique. So in today's topic I will discuss how to solve critical problems in block diagram reduction technique. So let us start the today's topic. How to solve critical problems by block diagram reduction technique. So to solve the critical problems in block diagram reduction technique, so we have to follow some steps so that we can easily solve the block diagram problems by reduction techniques. So the first step, the step 1, find the canonical forms. Find the canonical forms. For example, this is the canonical forms. So this is the canonical forms. This will be negative feedback, and this is the forward path transfer function and one feedback path transfer function. So if the canonical forms present in the block diagram, first you have to solve this canonical form, that is the transfer function of this, that is C of S by R of S is equal to G of S by 1 plus G of S into H of S. So this is the first step. You have to solve the canonical forms. Then the step 2, the step number 2, find any forward path loops. If there is forward path loops present in the block diagram, then you solve. So this is the forward path, that is G1 of S, and this is the G2 of S, like this. If there is any forward path loops, then you solve the forward path loops. This is the step 2. Then next, the important step, if there is no canonical forms or forward path loops are found in the block diagram, step 3, you follow first operate summing point and block. It means you have to move the summing point beyond the block or ahead of the block. Then if the problem is not solved by moving the summing point beyond the block or ahead of the block, then you follow the step 4, operate, take off point, and block. It means you should move the takeoff point beyond the block or ahead of the block. If the problem is not solved by moving the summing point beyond the block or ahead of the block, or by moving the takeoff point beyond the block or ahead of the block, then the next step we have to follow, that is step number 5. Operate takeoff point and summing point. That is, by moving the summing point or takeoff point beyond the summing point or ahead of summing point. So by operating these 2 points, that is takeoff point and summing point, the problem sometimes become more complicated. Therefore, you should not operate this. If the problem is solved by moving block and summing point and takeoff point and block, in the last case we have to operate the takeoff point and summing point. If the problem is not solved by moving takeoff point block or that is your summing point block. Therefore, by operating this, sometimes our problem is solved, though it becomes more complicated. Therefore, these are the steps to follow before solving any critical problems in the block diagram reduction techniques. So now take a simple block diagram problem and I will show you how to solve step by step. So let us start the problem. So problem is, find C by R, that is overall transfer function of following block diagram. So this is the problem. We have to find out what is C by R, or overall transfer function of the block. So let us draw the block diagram. This is the block diagram. have to find out what is C by R, or overall transfer function of the system. So this is plus, this is also plus, this is plus, this is also plus. This is H2 and this is minus G2, and this is your G1, G2, G3, is your G4. And this is H3. This is minus this is minus and this is H1 minus so this is your problem. So you have to find out what is C by R, that is the overall transfer function. So according to I have discussed the steps we have to follow to solve this problem. So if we will follow those steps, then it will be very easy to solve the problem. So already I have discussed the main disadvantage of block diagram reduction technique. There is no fixed starting point to solve the problem. Therefore, step 1 we have to find out the canonical form. So here is one canonical form. So first step we have to solve this canonical form. So here one forward path transfer function, this is the feedback path transfer function, and this is negative feedback. Therefore, the transfer function is G4 by 1 plus G4 H2. So you have to replace this. We have to replace this. The canonical form, this becomes one block, that is G4 by 1 plus G4 H2. So this is the step 1. This is the step 1. This is C. So next step is there is no forward path loops. Therefore, we have to change any summing point, or we have to move the summing point or take up point beyond the block or ahead of the block. So before moving that, already we know that these two blocks are connected in series or in cascade. Therefore, we can combine these two blocks, that is the product of or multiplication of two individual transfer function, that is G3, G4. plus G4H2. So now we have to operate this. We have to operate this takeoff point. That is, if we will move this takeoff point to this side, then the problem can be easily solved. Then next step, we have to move this takeoff point beyond this block. So we have to move this takeoff point beyond this block. So we have to move this takeoff point beyond this block. Therefore, this is now this becomes H1 divided by G3 G4 by 1 plus G4H2 G4H2. Okay, so now these two blocks are connected in cascade or in series. Therefore, this becomes one block, that is G2, G3, G4 by this much 1 plus G4H2. So now the problem becomes more simple by solving this. So let us find out any other canonical forms. So already we have find out these canonical forms, that is, this is the forward path block and this is the feedback path. So that is negative feedback. Now we can solve this. So if we will solve this, then the transfer function of this, that is G2, G3, G4 by 1 plus G4H2 divided by 1 plus G2, G3, G4 by 1 plus G4H2 into H3. So if we will take LCM here, this will be 1 plus G4H2. So this will be 1 plus G4H2, this will be cancelled. So now we will remove this. So G2, G3, G4 by 1 plus G4H2 plus G2, G3, G4H3. So this is the transfer function. So now these two blocks are connected in cascade. Therefore, this will be combined to one block, that is G1 G1, G2, G3, G4 by 1 plus G4H2, G2, G3, G4, H3. So now there are two feedback path. So here the feedback is 1 and here the feedback is, that is H1 into 1 plus G4 H2 by G3 G4. So you can remove this, that is H1 into 1 plus G4 H2 by G3 G4. So now we can combine these two feedback to a single feedback. So this will be combined to single feedback, that is 1 plus H1, 1 plus G4 H2 by G3 G4. So this will be combined to single feedback, that is G3 G4. We can take LCM. This will be G3 G4 plus H1 into 1 plus G4 H2 by G3 G4. So now this is the negative feedback. Only one canonical form is there. Therefore we can solve easily now this canonical form. So now this will be G1, G2, G3, G4 by 1 plus G4 H2 plus G2, G3, G4 H3 by 1 plus G1, G2, G3, G4 divided by 1 plus G4H2 plus G2, G3, G4, H3 into, this will be that is G3, G4 plus H1 into 1 plus so let us start here to avoid the complication. So this will be G1, G2, G3, G4 by 1 plus G4 H2 plus G2, G3, G4 H3 divided by 1 plus G1, G2, G3, G4 by 1 plus G4H2 plus G2, G3, G4, H3 into G3, G4 plus H1, 1 plus G4, H2 by G3, G4. So this G3, G4 will be cancelled.